This is the second part of the Chapter 3 lectures, and so far we have learned how to determine the density of liquids, and in this lecture we are going to learn to convert mass fractions to mole fractions and vice versa, and determine the average molecular weight of a mixture. So we saw that the density of liquids is found using the specific gravity, which you can find in the back of your textbook or online, or handbooks of chemical engineering or whatever. So when we talk about the density of ethanol, okay, this is meaningful if we have pure ethanol, okay, and the units are 789 kilograms per meter cubed. So let's say that we have a mixture of ethanol and water. So let's say we have 16.2 mass percent ethanol. Okay, so that means that we have 16.2 grams per 100 gram of mixture, okay, or solution. And we also can talk about this in terms of the mass fraction. Okay, so if we divide the percent by 100, then we will get the mass fraction. And that the mass fractions in a solution should add up to 1. So if we know the mass fraction of one of the components, the mass fraction of the other component, if there's only two components, would be 1 minus the mass fraction of the one component. So what is the density of a 16.2% solution? Well, we saw the table of data. We can find from the table that the density is 971.7 kilograms of solution per meter cubed of solution. And I want to point out that this density is has the same units as the pure species density, but the values are different. Okay, and we can talk about then the concentration. If we take the mass fraction, okay, and we multiply this by the solution density. So let's take a look at the units here. You might say that a mass fraction has no units because it's kilograms divided by kilograms. However, the numerator is kilograms of one of the components divided by the mass of the entire solution. So you should write those units. Don't just leave it as 0.162, because that's a good way to make a mistake then. Okay, so now notice here, when we multiply this by the solution density, we have kilograms of solution in the numerator divided by meter cubed of solution in the denominator. And so we multiply that out, we now have kilograms of ethanol per meter cubed of solution, which is a concentration on a mass basis. Okay, so let's talk about converting between mass and mole fractions. We saw that our mass fraction was 0.162 kilograms of ethanol per kilogram of solution. So to convert to a mole fraction, all right, we choose a basis for our calculation. If you're starting with a mass fraction, pick a basis of mass. Okay, and we will see that if we are trying to calculate a mass fraction from a mole fraction, we will then start with a basis of moles. But here we have mass fractions, we choose a basis of mass. So let's choose 100 kilograms as our basis. So that means in our solution we have 16.2 kilograms of ethanol and 83.8 kilograms of water. So now we can calculate the mole fraction. And we just take the mass of ethanol divided by the molecular weight of ethanol, and we put the same in the denominator. Mass of ethanol divided by the molecular weight of ethanol. And we add it to the mass of water divided by the molecular weight of water. Okay, and that gives us our mole fraction of 0.0703. So now if we start from the mole fraction, okay, then we start with the basis of moles. All right, so let's start with 100 kilogram moles of solution. So we have 7.01 moles of ethanol and 92.99 moles of water. So we can so how do you know that? If this is our mole fraction, then 1 minus this value will give you the mole fraction of water. Okay, and we can multiply the mole fraction times our basis to get the amount of moles in our solution. So then we calculate the mass fraction. This time, instead of dividing by the molecular weight, we multiply by the molecular weight. Okay, and you can, you don't, strictly speaking, have to memorize this process, because here you're going to end up with kilograms divided by kilograms, because the kilogram moles is going to cancel out in the numerator and in the denominator. Okay, so our mass fraction, we come back to our original of 0.162. So just to summarize, we found the mole fraction, we found the mass fraction, and we calculated the concentration. And again, this is to show, in order to calculate the concentration, we need to know something about the solution density. So how do we calculate the average molecular weight? Well, it turns out we actually did calculate the average molecular weight already. We made this calculation in the denominator, okay? The only thing we need to do with that is divide by the basis. And remember, we chose a basis of 100 kilogram moles. So if we take that, this mass times the molecular weight of each species, okay, that's in the solution, note that this plus this adds up to our basis of 100. Okay, so this is the formula written out in a summation. It's the sum of the mole fraction times the molecular weight. So in our case, we multiplied by moles, but essentially 7.03 divided by 100 is the mole fraction, and 92.97 divided by 100 is the mole fraction of water. So we did the same thing as in this calculation. Okay, so this is the exercise 3.2 for the video quiz. A mixture of 50 weight percent methane, 35 weight percent ethane, and 15 weight percent propane. Determine the mole fraction of methane in the mixture and the average molecular weight of the mixture.